Today I am going to demonstrate a very common and popular titration between oxalic acid and permanganate redox system. Oxalic acid versus KMnO4 titration is very popular and interesting redox reaction where one oxidant taking n number of electron and converted to a reductant. For any titration, we have to familiar different solution or equipments. Here also for redox reaction, we have to familiar with few words like tritant, which present in the burette, analyte, which is inside the conical flux, indicator, which is used in titration, which indicate the equivalent point of the titration, primary standard solution, secondary standard solution, etc. And all these solutions are redox active. Reaction of potassium permanganate and oxalic acid in acid medium is very interesting. By this reaction, many purpose can be achieved, like estimation of oxalic acid or potassium oxalate by permanganometry. Someone can measure the amount of oxalic acid and potassium oxalate in a mixture using this method, or can find the strength of unknown oxalic acid or potassium oxalate in a mixture or separately by this method, as well as the opposite phenomenon like standardization of unknown KMnO4 solution by standard oxalic acid solution in acid medium can be achieved. So before going in details of this reaction, I would like to discuss some feature of oxalic acid as well as KMnO4. Oxalic acid or potassium oxalate are generally called primary standard solution since they found in pure solid state and they are not affected by external factors like oxygen, moisture, light, carbon dioxide, bacteria, etc. They can be preserved for a long time in a closed container like volumetric flask, and the strength does not alter on staying for few days. So they are called primary standard solution and they can be measured directly using analytical balance. On the other hand, potassium permanganate called second standard solution, since few amount of manganese dioxide present as impurity, so we cannot weigh out potassium permanganate directly using analytical balance or exactly. Another point is potassium permanganate solution reacts with organic matter vigorously which are present in water. And last one is that potassium permanganate solution is affected by direct sunlight, so it is called secondary standard solution. Preparation of primary standard solution, here oxalic acid or potassium oxalate is chosen as primary standard solution, which are very good reducing agent, and the E0 value of oxalic acid is equal to minus 0.49 volt, and the corresponding half cell reaction as shown here, which is 2 electron transfer reaction. So one can calculate the equivalent weight of oxalic acid using the equation, the formula weight divided by the number of electron transfer in the half cell reaction. So here, since oxalic acid contain 2 molecule of water, so its formula weight is 126 divided by 2 electron transfer, so 2 equal to 63. Hence the equivalent weight of oxalic acid equal to 63. Now we can use this equivalent weight to prepare the normal solution of oxalic acid. As for example, here we chosen 250 ml N/20 oxalic acid solution. So one can easily calculate the amount of oxalic acid required to prepare 250 ml N/20 oxalic acid solution using the following equations. Here for 250 ml N/20 oxalic acid solution require 0.7875 gram solid oxalic acid, Again, for this purpose, since it is primary standard solution, we have to use analytical highly sensitive digital balance with high accuracy. In this case, we follow the weight transfer method for taking the almost exact oxalic acid as required. The first weight is the initial weight, then portion wise of oxalic acid is transferred into the volumetric flask through a funnel, and then take the final weight, and the value of the factor must be in the range 0.8 to 1.2, and that will provide the weight transfer when we subtract final weight from the initial weight. Here this value is 0.7913, which is almost very nearer to our weight required, 0.7875 gram. And these all data are noted in the tabular form, and the factor as well as the strength of oxalic acid can be calculated using the following equations. The factor is equal to the weight transferred in gram by weight to be taken in gram. Strength of the oxalic acid can be calculated by multiplying the factor by n by 20. Since we want to prepare n by 20 order oxalic acid, in this case our strength of oxalic acid equal to 0.0516 normal. Now the solid oxalic acid which is transferred in the funnel is dissolved using distilled water and shake well and make up to the mark in the volumetric flask as shown in the video.
Preparation of secondary standard solution, that is potassium permanganate. As we know, potassium permanganate is oxidizing agent and its inert value is equal to 1.51 volt in acid medium. So for the preparation of 500 ml n by 20 potassium permanganate solution, we have to follow the half cell equation like this, which is nothing but 5 electron transfer reaction, and its equivalent weight is equal to the formula weight by number of electron transfer, that is 158.03 by 5 is equal to 31.6. For the purpose of preparation of 500 ml n by 20 KMnO4 solution, we need 0.79 gram solid KMnO4. And for preparation the solution, we have to follow the following steps. Number 1, at first weigh out almost 0.79 gram solid KMnO4 roughly using a rough balance, or 0.00 accuracy. Next one, dissolve it in an ambered glass bottle with pure distilled water, about 500 ml. Since potassium permanganate is affected by light, so we have to prepare or preserve the solution in ambered bottle. Next, stir or shake the solution till all solid potassium permanganate get dissolved. In this purpose, magnetic stirrer can be used, or this method or this step can take few hours or even overnight. Next, after dissolving all the particles of potassium permanganate in water, we have to filter the solution in another amber glass bottle through a funnel containing glass wool to separate insoluble manganese dioxide as impurity. Here I would like to mention an interesting fact that here we never use filter paper, since filter paper is made of cellulose, that is organic matter, and potassium permanganate oxidize this organic matter and get reduced in different form. So loss of KMnO4 takes place. We have to use glass wool which do not react with potassium permanganate. Now we have to preserve the bottle, that ambered glass bottle, in dark place protected from direct sunlight. Since sunlight, in presence of sunlight, KMnO4 get dissociated. And the last one, this solution is ready to use as oxidizing agent to titrate with oxalic acid solution in acid medium. Now the titration procedure. Here potassium permanganate used as tritant and taken in a burette, and oxalic acid is pipetted out in a conical flask. At first 25 ml N by 20 oxalic acid taken in a conical flask using pipette, and then since the reaction is taking place in, or the titration is taking place in acid medium, so here we use 4-normal sulfuric acid to maintain the pH of the solution. So we add 25 ml 4-normal sulfuric acid using measuring cylinder and shake well the mixture. Interestingly, this titration must be done in hot condition, and the temperature of the solution must lie between 70 degrees centigrade to 80 degrees centigrade. For this purpose, we have to heat the conical flask containing the mixture of solution on a Bunsen burner till the temperature rise about 70 degrees centigrade to 80 degrees centigrade. But why we require this temperature for this titration? Actually, at room temperature, that is 25 to 35 degrees centigrade, if we proceed the titration with KMnO4 solution, KMnO4 form a complex with oxalic acid like K3MnOx3, which is very stable under this situation, that is below 60 degrees centigrade. But our purpose is to follow the equation like MnO4 to Mn2 plus to completion the titration. But here in this complex, Mn become +3 state and it is stabilized with oxalate. So the result will be erroneous. So we have to decompose this complex and need the solution temperature must be greater than 60 degrees centigrade. So we heat the solution 70 degrees and above. Why we do not heat the solution at 100 degrees centigrade or boil the solution? Why we maintain the temperature in between 70 to 80 degrees centigrade? Because when we boil the solution of oxalic acid and H2SO4 mixture, oxalic acid get decomposed and carbon dioxide and water is released. So again the titration or the result is erroneous. Now how will you know the temperature of the solution reach at 70 degrees centigrade to 80 degrees centigrade without using any thermometer? Because when you use thermometer, loss of reagent or analyte takes place. We apply an interesting technique to know the temperature of the solution, whether it reach at 70 degree or above or not. If we use Bunsen burner as a heating medium, in Bunsen burner we use LPG gas. LPG is nothing but the mixture of liquefied petroleum gas like propane, butane and pentane. And when we burn these gases, it will produce carbon dioxide and water, and this hot water get vaporized and attached with the outer wall of the cold outer wall of the conical flask and get condensed and produce a water vapor layer. When during heating this water vapor layer outside the conical flask wall get vaporized again and it become dry and few amount of vapor get released from inside the conical flask, then the solution temperature just cross 70 degrees centigrade.
Now during the titration, an interesting observation can be experienced that after addition of 2 to 3 drops of KMnO4 in the oxalic acid solution, the whole solution become pink at the beginning. But it is why? One of the important example of auto-catalysis reaction. The overall reaction is shown here. Oxalic acid transformed to carbon dioxide and permanganate transformed to manganese 2 plus. This reaction is very slow at the beginning if spontaneously takes place. Since permanganate, where manganese plus 7 oxidation state being D0 system, having pink color and turns into as a whole pink solution after addition of just 1 or 2 drops of KMnO4 into the reaction mixture. But why? Before proceeding the titration, we have to warm the solution about 70 degree to 80 degree centigrade temperature as mentioned earlier. Supplying heat energy as well as the shaking of the solution will provide the mechanical energy to the system to initiate the above reaction rate and produce few molecules of product Mn2 plus at the beginning, which is nothing but D5 system as shown in the above equation. As soon as this Mn2 plus is produced in solution, which now catalyze the reaction and the rate of the reaction become faster. So after vigorous shaking, the pink color of the solution disappeared as shown here. And now we observe that addition of a drop of pink KMnO4 to the hot oxalic acid solution at once discharges the color of the solution, and then one can continue the titration till the pink color appeared second time and persist at least 30 seconds or more. This indicates the endpoint or neutralization point of the titration. Another interesting feature of this titration is the indicator. What is the indicator used in this titration? The color of KMnO4 is very dark pink or purple, and hence we can spot the distinct color change from colorless to pale pink at the end point of the titration.
It is due to the very high molar extinction coefficient of KMnO4, which is denoted by epsilon, and hence it can produce intense pink color of the solution in our visual region.
1 drop 0.1 molar solution of KMnO4 can produce distinct pink color of 100 ml colorless solution. Hence, here potassium permanganate used as a self-indicator.
Now the burette reading of KMnO4 solution is noted as tabular form, and the strength or the amount of KMnO4 can be calculated using the following equation.